drink gallons of red wine.
500 glasses a day.
Well, that's not such a bad thing.
But you can translate it to a pill that will have the same effect. Am I right or wrong?
That's right. That's right. Now, I think, and a lot of people do ask me, you know, is it wise to take these pills?
Yes.
And the pills that are on the market now are mostly produced from plant extracts.
Right.
So resveratrol and the broad class of compounds of which it's a part, called polyphenols, are made by plants in response to stress. So they can be prepared. So you can go online, type in resveratrol, and get vendors that will sell this. Now, David Sinclair, for example, takes
said so on this program.
Exactly. I myself am a little bit more cautious.
Because you worry about what?
What's in there. So first of all, you have to take quite high doses. So the amount of wine, Bob, would actually be something like 1,000 bottles a day. That you would have
really? Glasses or bottles?
Bottles that you would have to drink.
Bottles.
That's beyond my capacity, Butler.
Well, you mean 1,000 glasses would have been okay?
Yeah, it would have been okay.
All right.
But it's not just what's in there.
Yeah.
It's whether or not it does what we think it does and whether there's any harm. And that hasn't been evaluated in people yet.
It's a broader issue of nutraceuticals, I think. It's
a broader issue of
things that are sold at the health food store.
Okay,
They're not controlled for quality.
Cynthia, let me go back to you to finish your
and
point.
I'll make it brief. Okay, so basically what we found is that lowering the level of this hormone, making cells so that they can't respond very well to a hormone, makes the animal live longer. So the hormone is like the Grim Reaper, in a sense. It's making the animal grow old faster. And what we found is that the reason that the animal lives longer when there's less hormone is because hormones control the activities of lots of different genes. So what we found is this hormone controls the activity of about 100 or more genes in the DNA. It makes them some more active and some less active. And what happens is when we have less of the signaling through the less activity of the hormone, lower activity of the hormone, the animals shift their physiology from, as Lenny said, a state of growth, a kind of happy-go-lucky state, to a more hunkered-down state. They activate genes that fight infections, that make proteins that behave as antioxidants, that protect the proteins and other parts of the cells. They affect the metabolism in other ways, fat transport, and many other things. So there's not just one way that the animals live longer. They basically are pulling out all the stops, and what they're doing is protecting the cells in many different ways from conditions that cause aging. And it's interesting, I went to the caloric restriction website recently, and it turns out if you want to calorically restrict yourself, what they say is the first thing that you should do is to go on a low-carb diet, because sugar is what makes you want to eat more. If you don't eat sugar, if you eat less sugar, and then you're not as hungry. So it's a lot easier to eat less if you want to.
It's not something you'd have predicted. I mean, quite different directions, different organisms, different studies, all coming together. Now, I think, what are the other consequences for aging? I mean, I look at Robert here. I mean, we're looking at
He's 150.
Yeah. What else do you think we should be thinking about here? Listening to these basic scientists, are you optimistic? Sorry, that's just...
I am optimistic. I am optimistic because I think the science is beginning to be there. I think it's very important we don't be misunderstood. We certainly favor the continuing study of specific diseases, but we think it's time for a complementary infusion of new funds to really address the possibilities that are so rich and possible, as has been expressed here this evening.
How far do you think we could go? I mean, you know, we die at 85, 90, 95. Is it 120? Is it 130? Is it 115?
Just for a small little factoid, the oldest person we know is 121?
122 and a half.
It was a woman in France?
Jean Calment, woman in Arles, France.
In France. Okay, go ahead.
Well, I mean, we had this 30-year rise in life expectancy. There's a big debate now about how much further this can go. Some of us, myself among them, believe that without any of these aging interventions, we might be able to push female life expectancy up to about 88, which is about 8 years higher than we are now, and that's a huge increase.
Push it there over what period of time? In the next 5 years?
Sometime in this century. Okay. We think, I don't know, we don't know
so over
when.
the next 93 years.
Yeah, within this century. Female life expectancy up to about 80. Female life expectancy 88.
Doing what? How would
through
we do
diet, exercise, the things that we know that we can do today without intervening in the aging process, including existing biomedical interventions. You have to realize that even if we came up with a cure for cancer today, if there was some, monumental success, it would only raise life expectancy by about 3.5 years. Heart disease, a bit more than that. So you have to realize that going after these diseases one at a time is going to yield relatively small incremental increases in longevity. Some improvements, certainly improvements in quality of life for the individuals who have these diseases. But we run the risk of doing something that we don't want to do, and that is extend the period of old age. In other words, if you don't die from heart disease, you don't die from cancer, you may live long enough to get Alzheimer's disease, to experience it at a much worse level than you might otherwise experience that condition. So
I want to come to one point. This notion that in cells, that cells multiply, and I mean, multiply, or divide, whatever the way terminology
good,
is.
Isn't it? Multiply or divide. It's always so confusing.
What do we know about somehow that there is in the cell, built in a kind of end of the journey?
Well, we've touched briefly on that, and Lenny, I think, could expand further, but there are these chromosome ends. And one of the things that have been really quite well worked out is that when mammalian cells grow in isolated culture, these chromosome ends can get shorter and shorter and shorter. And that leads to a limit. It varies from cell type to cell type, but it gets to a limit. Maybe they double 20 times, 30 times, maybe up to 50 times. But there seems to be a limit beyond which the normal cells cannot go. And one of the interesting things is how that relates to this whole process of
exactly.
aging.
That's my point.
And
so,
I mean,
tell me.
I think the stress point that Lenny made earlier, we know from studies of women who had children that were healthy compared to women who had children who were diseased, that the shortening of those telomeres was greater in those that had to face that kind of terrible stress. So along with starvation,
I think I would